go. The binary mixture, I can tell you this. The binary mixture is a mixture. I mean, it's got two unique components, and you're going to separate them by physical means. Right? They contain sodium chloride and sand. Right? That's primary formula for sand, silicon dioxide. But you don't know how much is which. So what we want to do is determine the percent by mass of each one. That's the question. Okay, let me get the method out. Where's my copy? Did I leave it someplace? Or did I put it back up here? Did leave it out somewhere. I must have, if it's not in here. All right. Write it down. See it right here. It says key in there, right? Okay. Remember, mixtures can be separated by physical means. Only compounds have to be broken apart by chemical means. So physical means will separate. This is an interesting flow chart on page 62. Where you take, you're going to have basically two beakers. The first beaker is the one where you're going to dissolve. You're going to put this mixture into water. And guess what happens? That one goes into solution, and that one doesn't. That's the separating factor. Solubility. This one's soluble, that one's not. So when you do that, when you mix this in water, then all you have to do is filter, run this through a filter, and the sodium chloride solution goes through the filter and ends up in a second beaker. Okay, so now you got them separated. You got to determine the mass of each one. So what's behind in the filter paper is this one. And what ends up in the beaker below is this one. So you got to dry them. So the one with the sodium chloride, you just put it right on the hot plate and you boil off the water. Right? And this one is in the filter paper. So you take the filter paper on a watch glass and you set it on top of the boiling water, and the steam, the heat from the bath will evaporate the water from your sand. So that, in simplest terms, that's the separation. Now the trick is to get the masses for each while you're doing it. Okay, so when you've separated these two, if the sodium chloride ends up in this beaker, right, ends up in that beaker, this is sodium chloride aqueous. How do you weigh that and get the weight of the sodium chloride after you boil off all the water? You got to know how much the beaker weighs, right? So you got to get a weight for the beaker before you filter anything into it, right? And there's a table for that over here somewhere. Let's see. Yeah, it's on page 71. So if you know the mass of the beaker before you put anything in it, and you weigh it again after you've dried it down, the difference is the sodium chloride. Okay, so you got the mass of the sodium chloride there. How about this one? This one is in the filter paper. Right, so you got something in the filter paper, but it's wet. So you dry it. Right. So how do you know what the mass of the silicon dioxide with sand is once you dry it? You got to know the weight of the filter paper. In fact, you want to know the weight of the watch glass too, just in case some of it spills over onto the watch glass. So you're going to have the mass of the watch glass and the mass of the filter paper together first. Then when you put it in the filter, in the funnel, put it in the funnel, right? And the liquid goes through. Actually, this is the same beaker as that one. The liquid goes through. Then what's behind in the filter paper is your sand. So you take that filter paper out, you put it on the watch glass, and then you put it on another boiling water bath here. And that heats it and drives off the water, the moisture. And now you have dry sand in your filter paper and the watch glass. So now you have, if you have the weight of the watch glass plus the filter paper first, then after it's dried, you go weigh it again. You know now the difference is the weight of the sand. Okay, that's the procedure. And then to calculate the percent, you know the total mass before you even get started, because your samples are right here in these little cups. Okay. So that's why one of your first instructions is put this on the balance. What's the mass? And then transfer all of this stuff here, this mixture, into another beaker. Beaker number one. Quantitative transfer. Then you get everything out of it into the beaker. And then you can weigh this again. So what's the difference? Weight of the constants. Okay. You subtract the weight of the container from the total weight, and that's the weight of the sand salt mixture. Starting. Okay, there's a number on each one. So there's a place to record the sample number in your sheet. All right. So let's look at pre-lab questions in case they're useful information here. Pre-lab. Erase this. Pre-lab questions. Read an authoritative source for a discussion of filtration. Okay, I doubt anybody's done that. What is filtration based upon? It's based upon particle size. If you've got something in solution, then the solution has dissolved in it something, and the particles are small enough, they'll go right through the filter. And anything that didn't dissolve or has particles big enough for the filter paper will get caught in the filter paper. It's purely physical separation. So number two, what safety precautions should be taken when evaporating the filtrate containing sodium chloride? Well, sodium chloride is in the solution, and you're going to put it directly on the hot plate and boil off the water. So what do you have to consider when you do that? Well, you may not know this, but as the volume decreases, then you start to get hot spots, because water is going to, you're going to reach the saturation point as the volume decreases. Some of those crystals are going to come out of solution, and they create hot spots on the bottom of the container. That means that when those crystals of sodium chloride get hot enough, they're going to transfer that heat to water, and it's going to instantly burp, which would spatter. Okay, so in the beginning, you can boil it at a pretty high heat, but as the volume decreases, you need to turn the heat down slowly, gradually, until it's pretty low for the very last stages of drying. You want to avoid spattering. Then the other thing you're drying is the filter paper with the sand on the watch glass, and it's over what we call a steam bath. That water's boiling underneath, and its only purpose is to produce steam that hits the watch glass and heats the filter paper and dries it. Okay, so there's a steam danger there. You can be scalded with that steam. So that means wear your PPE, personal protective equipment, lab coat, eye protection. I'd wear gloves too. That'd give you an extra layer of protection. That was 2. 3, define the following terms as they apply to this experiment. Homogeneous mixture. Right? What's characteristic of a homogeneous mixture? The components, I should say this, the percent composition of all the components is uniform throughout. Any place you sample that homogeneous mixture, you're going to have the same concentration of the components. So that when you filter that water through and you get the sodium chloride solution in your second beaker, that's a homogeneous mixture. It's a solution of sodium chloride in water. Let's see, that was first part. Second part. Evaporation. What is evaporation? I'm sorry?
Heated to remove.
Yeah. You convert a liquid to a gas to remove it from whatever. Usually by heating. Now you can also convert liquids into gases by reducing the pressure. Right? At lower pressure, then you can evaporate liquids at lower temperature. Right? Sometimes you can even convert, well, actually, that would be different. Evaporation is liquid to gas. I'm thinking of sublimation, going from solid to gas. But if you reduce the pressure, then you don't have to put as much heat into it. Okay, evaporation. 3, residue. What do we mean by residue? Well, we can think of it in 2 different ways. After you evaporate the solvent, what's left behind is the residue. So sodium chloride would be the residue from evaporating that liquid, or whatever is retained in the filter. So the sand or silicon dioxide is a residue for filtration, and salt is a residue for evaporation. Okay. Number 4. A student was asked to determine the percentage of each component in a mixture of sodium nitrate and calcium carbonate. All right, so we've got 2 components in this mixture, sodium nitrate. Yeah, sodium nitrate and calcium carbonate are the two components in the mixture. The mass of the sample is 2.21 grams. So the total mass is 2.21 grams. The student extracted sodium nitrate from the mixture with water and separated the insoluble calcium carbonate from the solution by filtration. Okay, so they did the same thing we're going to do, only these were different. This would be comparable to our salt, and this would be comparable to our sand, because calcium carbonate doesn't dissolve in water. It's insoluble. So after evaporating the filtrate, the student recovered and dried the sodium nitrate and found that it weighed 0.43 grams. So afterwards, 0.43 grams of that was recovered from this sample, and 1.67 grams was recovered from the filter paper. Okay. Let's see. All right. So the next page says, on the basis of the mass of the sample used, calculate percent sodium nitrate in the mixture. So the 1A, calculate the percent of sodium nitrate in the mixture. 0.43 grams per 2.21 grams times 100. That'll be the percent of the sodium nitrate in the sample. Okay. And this will be the similar process for what you're going to do. All right, I'll let you calculate that value. Also calculate the percent of calcium carbonate in the sample, 1.67 grams per the same total, 2.21 times 100. That'll give you the percent composition of calcium carbonate in the sample. So, let's see. Two says calculate the total mass of sodium nitrate and calcium carbonate recovered. So that would be this one plus this one. This is recovery. 0.43 plus 1.67 equals something, some value. Okay. Now, I can look at that number. It's 2.10 grams. Notice that the recovered amount is not the same as we started with, right? We lost something somewhere. Okay. So what's the percent recovery? That's step 3. The percent recovery is this amount that was recovered divided by the amount we started with times 100. That's the percent recovery. Okay. And number 4. Calculate the percent error for the separation of the components. The percent error is the percent difference between these two numbers. So we started off with 221 and we ended up with 2.10 times 100. Right. So that's the expected value, the actual value. So that'll give you a percentage recovery. Okay, I think all those calculations are ones that you'll be doing for this experiment. That's it. Those are the pre-lab questions.
So number 5. Mass of bigger tube, the NaCl Do you pour the sand in between